Yeah, so again, thank you for having us. We're really excited to be here. My name is Christine, and I work for DrivenData. So today, our talk is called From Pixels to Predictions. And so we run machine learning challenges, many of which have used remote sensing products. So we're going to go over a few of those challenges today. So our talk will probably take the full 40 minutes, and hopefully we'll have plenty of time for a Q&A at the end. We're going to do a brief overview of what we do and how we do it, how the platform works, go over some upcoming challenges we think you all would be interested in, and then the bulk of the presentation will be on past challenge overview. And so we've got 3 different competitions that we want to go over. We have some high-level slides, but I wanted to pause and ask the group what they are particularly interested in hearing about or interested in, or what kind of perspective they want to know about. So feel free to chime in.
I'll hop in. I'm the chatty one. I'm interested in your guys' approach for managing these competitions and sort of driving innovation. I think that is such an interesting way to, build capacity and foster capacity and really sort of find solutions. So I think I'd love to hear about that. I know you guys are going to highlight that, but that's, I think, a really, really cool element.
Yeah, we'll definitely talk about that. And Katie will be talking about the harmful algal blooms challenge, where we actually took some of the winning solutions and packaged it into a library for people to download and use as an open source tool. So yeah, very happy to talk about that. All right, if anyone thinks of anything else, feel free to chat or just chime in. After each of the sections, we'll pause for questions, but feel free to just, ask a question, whatever. So yeah, quickly, we all work at DrivenData as data scientists. We're a pretty small team of 12 people. And we do 2 things. One is the machine learning competition that we'll be talking about today, and the other side is consulting. And so all of us do a little bit on both sides, or a lot of it on both sides. So what we do, why do we work on machine learning challenges? Well, they bring together a large and active community to focus on a concrete problem. So we'll talk about their benefits. Isha will diagram the mechanics of a competition, and then we'll do a deep dive into a few examples. So why would anyone come to us to run a machine learning challenge? Well, we think they're really good at solving hard problems where the best approaches are not evident at the outset. And so a lot of the clients that come to us are nonprofits, academic researchers, people who have a problem they want to solve, and some talent, but maybe not a whole team to dedicate a lot of time and money and resources to solving this problem in the best way possible. And so with a challenge, you can engage a large global community right away. There are over 100,000 people subscribed to our newsletter. Hundreds of thousands of people participate in every competition. We bring a wide diversity of backgrounds and skills, so everyone from students to professional data scientists and machine learning engineers. You can test hundreds or thousands of models quickly and cost effectively, so competitions typically run on the order of 3 months, and in that time, you'll get thousands of submissions. And we have our leaderboard, which is what you see on the right-hand side here. And this elevates the best performing solutions automatically to the top. And so for each individual, you can see their performance over time for each of their submissions. And then up top with the dots, you can see the best solution over time for the whole competition. And so machine learning challenges, they're a really great way of solving Joy's law, which says no matter who you are, most of the smartest people work for someone else. So I will hand it over to Isha to explain how we actually do that.
Awesome. Thanks, Christine. And I'm going to ask you to, I guess, flip as I talk. Thank you. So the way that I'm going to describe a few of our machine learning challenge mechanics applies very specifically to those instances where we're looking for a quantitative outcome. We do run challenges that involve searching for qualitative outcomes, perhaps like a visualization or some other sort of more holistic way, but the vast majority of our competitions are still quantitative. So that's what we're going through today. Generally, they start with the data itself. We have features that we want the participants to use to make predictions, and of course labels or the ground truth that we want to compare those predictions against. Generally, these come to us through our partners, and we split them into a training set and a test set. Then what we make public is the training set for the features, the labels for the training set, and the test set of the features as well. So the idea is that participants will be able to use the training data, both the features and the labels, to train their model. And then using that model, they will make predictions on this test set of features that we've provided. And we then expect them to return a test set of predictions, often in some sort of format that we've specified beforehand. And then we'll go ahead and compare those predictions to the test labels, which we've not made public. We have those on our end. And generally, the sort of product will be a score using a metric that we have sort of come to a decision on with the partner that prioritizes the outcomes that they want to prioritize for. So, for instance, we'll be going through a few competitions later in our presentation, and each one of those metrics is like slightly different depending on what our sort of partner thought was the most important outcome to optimize for. And then these sort of between the comparison of the labels and the predictions and the score that is output, we have the leaderboard according to that. And generally, the public-facing leaderboard, which is there during the competition, reflects the performance on a portion of the test set, because we don't want participants to sort of like game the system by making a bunch of submissions and sort of like fitting to a test set in that way. So yeah, this is like basically how we conduct most of our competitions, but of course we have a lot of variations that can get pretty exciting. We have certain competitions that run where the submission period is something over a few months, and competitors have to submit something every few weeks for, say, like a now casting challenge. We also have sort of competitions where we ask competitors to submit their code to perform inference, and we have a test set of features that is entirely withheld as well, which prevents leakage. So there's lots of fun little variations about that, but this is the core setup for the competitions that we're going to be talking about today.
To give a quick teaser of what one of these can look like, which we'll talk more about later, one of the examples we'll discuss is a challenge predicting harmful algal blooms in water bodies. So in this example, those labels that Isha was talking about, those were manually collected in situ measurements collected by public health organizations across the US. So this was our ground truth. And the features for that competition were actually accessed through publicly available access points. So things like Landsat imagery, Sentinel imagery, NOAA climate data. So for the features, we provided participants with dates and locations, and that allowed them to pull features from various access points online. And then the labels that were generated by participants were these severity levels. And once again, we'll go into this in much more detail later, but just to give a quick example of what this can look like.
And today we're focusing mostly on sort of computer vision related competitions that used satellite data as at least one of their inputs. However, the sort of like model of a data science challenge, the basic motivations remain the same no matter which domain you're working in. It's as useful to sort of crowdsource solutions and have a metric that optimizes an outcome for, a challenge related to, say, sort of the Internet of Things, tabular data, which was the case in some of these competitions. There's also like NLP related tasks that could also benefit from the same sort of competition setup. So we have a bunch of data science challenges to this effect on our site if you're curious about learning about ones that don't involve satellite data as well.
I will add that more and more of our challenges are using some kind of remote sensed data product. And we're seeing a lot of competitions around monitoring. I think all three of our competitions that we're talking about today have a monitoring reason behind them. And yeah, so I'll stop there. The next step is jumping into some of our examples, but does anyone have any questions about the platform or how these competitions work? Mickey?
Yeah, I was curious if there's any like event associated with this or if this is all run online. I know you said over the period of 3 months, but is it all asynchronous, and how do you promote the event? Just over social media? How does that all work?
Yeah, so the vast majority are completely remote. So people engage via our platform. There also is a forum associated with each competition where participants can talk and ask questions. We mostly promote via social media. Some of our competitions have like a more academic bent to them, and in which case we might do specific outreach to certain like research groups and things like that. We have had competitions that have an in-person element. So last year we did a federated learning competition that had an in-person component in London. That's pretty rare, but it does happen. For the most part, promotion is done through social media, our newsletter. A lot of people just come to our website and look for new competitions, and everything is done asynchronously and remotely. Sarah?
Hi, Christine. I was wondering how you incentivize participation in this, and if some of the challenges that have greater incentives get better results.
That's a great question. So all of our competitions, or the vast majority, have a prize pool. So there are some just for fun competitions, and people will engage just to learn and have fun. But the vast majority of our competitions have a prize pool, and this can range anywhere from $10,000 to, I think, $500,000 was our biggest pot. That's over, multiple competitions. They might have like series, like part 1, part 2, things like that. But yeah, so these prize pots can get pretty big, and that is what incentivizes people to participate. People do like having fun though, and learning and just trying to rise to the top of the leaderboard. So there is that incentive. I will say the bigger the prize pool, typically the more engagement we see, and the bigger prize pool is also associated or correlates with the complexity of the problem. And so if it's a very hard problem, less well-defined, we're asking our participants to do more, there's typically a higher prize pool. Cool. Any other questions before we move on? Great. Yeah, and if you think of anything, just feel free to drop it in the chat. Before we get into our past challenges, we did want to make sure we talk about some upcoming challenges. So Katie, do you want to talk about what we've got?
So these are a couple of challenges coming down the pipeline that would be relevant to this group. The first is the pale blue dot visualization challenge. This one actually launches today. And the goal of this challenge is to increase engagement with publicly available remote sensing data, specifically as it can relate to the Sustainable Development Goals. So this is one of those more qualitative competitions that Isha discussed. In this case, participants will create a visualization, but this is a great competition to circulate for participants to just learn about and engage more with all of the remote sensing data that has been made available by various US government agencies. And there is a variety of resource going along with it to help folks get started with remote sensing data.
In 2 weeks, we also have the Kelp Wanted competition launching. This is sponsored by our friends at MathWorks, and the idea here is that it's a semantic segmentation challenge, and so labeling each pixel in Landsat imagery as kelp canopy or not. And this is helping researchers monitor the growth or loss of kelp forests in oceans around the world. Great. So now we'll dive into some past challenges. First, I'll go over the NASA Airathon, and this concluded last year in March of 2022. So as I mentioned earlier, this is a competition that we worked with NASA on, with one of your colleagues actually. Aaron Nager was our expert for NO2, which is one of the pollutants that we were trying to predict. And Abby Nastan was our PM 2.5 expert. So the idea here is that air pollution is a environmental threat to human health, and there isn't a single satellite instrument that provides ready-to-use high-resolution information on surface-level air pollutants. So we're looking for something that is high resolution and at a minimum daily temporal resolution. And so what we do have are high-quality ground monitors. These measure PM 2.5 and NO2, and a lot of the air quality measurements that you can look up are based on these ground monitors. However, these are expensive and there's large gaps in coverage. If you don't live near a city, you likely don't have estimates that are good for your location. And even within a city, the spatial resolution isn't very high. And so the idea is that can we use high resolution satellite imagery and remote sense products to build algorithms to create a high resolution, high spatial and temporal resolution prediction for these two pollutants that we care about that are harmful to human health. And so that's PM 2.5 and NO2. So the basic setup is that there were two tracks. One is the trace gas track predicting NO2, and the other is the particulate matter track, PM 2.5. We picked three cities that we cared about, so Los Angeles, Delhi, and Taipei. And in each of these urban areas, we created a 5 kilometer by 5 kilometer geometry around one of those high quality reference grade monitors that are on the ground. So this is open data that we pulled from OpenAQ, and we use this for both training and evaluation. And because there is such an important temporal element to this challenge, we only wanted people to use data in the past to predict, it was basically a nowcasting challenge, so prediction for the current day. We created an out-of-sample validation set, and so all winning solutions were tested on new data that was collected after the competition ended to make sure that any winning solutions generalized to new data and there wasn't some kind of temporal leakage. For input features, we used data from two different satellites. And so for the PM 2.5 challenge, we used the MAYAC and MISR products that come from the Aqua and Terra satellites. And for the NO2 challenge, we used the OMI and TRPOMI products that come from the Aura and Sentinel-5 precursor satellites, respectively. So these were the four main data sources that we required people to use depending on the track that they were in. People were also allowed to use ancillary data, and so this included digital elevation models and weather forecasts. For all of the four main data sources that I mentioned, we provided these in an S3 bucket. So we pulled out of the satellite data and made it available for people. People were also able to request new data sets. For these, people had to gather the data themselves. It had to be open, public, accessible for all competitors, but each competitor was responsible for collecting the data on their own. And so this was a pretty difficult challenge, non-standard, because there was this out-of-sample validation set, and also people were able to request and gather their own data sources. And satellite data can be pretty hard to work with. We had, I think, over a terabyte of data on our S3 bucket, so it's pretty large data to work with. But we saw a lot of participation, over 1,000 participants, and the top scores were pretty good. So you can see these are the top three solutions for the particulate matter track. We created a benchmark that was just taking the mean values based on the satellite data for each location, predicting that same value for each of our gridded points. And you can see our competitors did a lot better. The metric is R squared, so higher is better. So all of our winners achieved around 0.8 R squared. On the right, you can see the results varied a lot by city. And so people did far better in Delhi than they did in Los Angeles and Taipei. This is for a couple of reasons. The first is that Delhi comprised the bulk of the data set. We had less data in Los Angeles and pretty small data set for Taipei. The other is that for PM 2.5 especially, Delhi had a lot of, I don't quite want to call them outliers because they happen very frequently, but the very, very high values compared to either LA or Taipei, and R squared is pretty sensitive to high values. And so if you can get those high values right, you will see a higher R squared. So you can see by city, we see pretty different results. And we saw the same thing in the NO2 track as well. And so our benchmark did fairly poorly, and our winners did much, much better, achieving between 0.4 and 0.5 R squared. And again, you can see different results by each city. LA, in this case, we had much more data than either Delhi or Taipei, and you can see how much training data you have affects how well your model performs. So the researchers that we're working with had, I would say, two primary goals in this challenge. So going into this, we knew that this could be done. There were papers written about it predicting pollution from satellite data, but it was unclear what models were the best. We didn't know if people were going to use tree-based models or deep learning models, or maybe just like some basic regressors. We also didn't know what data would be useful. So we had 4 approved data sets that we suspected would be useful, but we allowed people to request anything that they thought might be additionally useful. And so what we found is that almost actually all of our winners used an ensemble of tree-based models. And so this is a combination of XGBoost, CatBoost, LightGBM, Random Forest, and all of them used ensembles. And so the fewest just averaging 2 models together up to third place on the NO2 track averaged 200 models together. And so we saw this technique of ensembling tree-based models to be a pretty winning method. And while people did request some additional data sets, all of our winning competitors only used the pre-approved data sets in addition to weather forecasts. Yeah, so any specific questions about the air pollution challenge? Yeah, Biplav?
Yeah, thanks, Christine, for the presentation. I was wondering on the training data side, so you said that people could request additional data if they want to. Mm-hmm. And I'm not sure like how you are providing resources to this participant. Also linking those, does that mean like if someone has access to, let's say, higher computational resources, they would be able to run larger model versus subset of data sets that you have sort of as a minimum they have to use? Do you see any discrepancy going in that way?
Yeah, so all of our competitors are required to send us their solutions, and then we verify them at the end. And so we actually run their models. Sometimes we retrain them. We always perform inference again. And as part of that, they provide documentation that explains their models, how to retrain, and what the requirements are. And so because the data was quite big in this challenge, all of our winners did have more computational resources. A ton of memory, I think, was the biggest thing that was required, and also very good processors and things like that. So yes, that's definitely an advantage in these competitions. The more computational resources you have, you're not going to train, 200 models on terabytes of data on, any old laptop. So that's definitely an advantage, and we did see that. For the data that people requested, that we listed the approved data sources on our website, and we provided links where they could download the data and instructions on how to download the data, but we didn't provide anything beyond that for these additional data sets.
Okay, and sorry if I missed, if you said that they were required to bring their own label data sets or draw them, right?
No, we provided the label data set. So we created the data sets based on data from OpenAQ, and then we created geometries in the 3 cities that we cared about. And so ultimately you can kind of see it here, but so it was a very sparse grid, the labels, because the monitors are fairly sparse, but there would be, a little square scattered across the 3 cities, and each of those squares were assigned a grid ID, and so people predicted on a grid ID and a date time.
Okay, yeah, and I have one more question, and I think you touched a little bit on that. So I was also wondering what the review process on your end looks like. You said you run the code and the inference on your end as well. But also curious on understanding like how you select those matrices that goes into this model. Do you consult with in this case, Aaron Nager, who is the science POC, and like overall QA process that goes on your end?
Yeah, so for all of our competitions, we verify the solutions, which means the finalists have to send us their code, both for training and for predicting, so inference. And for the most part, we always run inference to make sure we can reproduce their winning results. We also do a code review. We make sure all of the packages can be installed, all of the code can be run, and sometimes training can take a long time. And so when possible, we'll retrain the model. Oftentimes, we are just starting the training process to make sure the code works, but not training the model to completion. So that is our QA process. And then we publish all of the models on a GitHub repo after the fact. All the models, for the most part, are open source and freely available for anyone to use, including the code to train and predict.
Okay, thank you. One last question, sorry. Is there, I'm pretty sure that is not the case, but has there been a case where, you had to invalidate the model because you couldn't train them, or, there is proprietary software or whatever used?
Yeah, that has definitely happened before. Sometimes there is purposeful cheating. Sometimes there is not purposeful cheating. And so in this case, we were afraid there might be like temporal leakage. People might use future data to predict and then do better. That did not happen with any of our winning solutions. It is also required that the code works. And so sometimes the code quality is not great and we can't reproduce the results. And that is also grounds for disqualification. So usually it's not malicious, but we have seen winners get disqualified because they inadvertently broke some rule, or we couldn't reproduce the results or something like that.
Gotcha. Thank you so much.
Yeah. And I think you had a previous question about metrics. Yeah, for this one, we consulted with Abby and Aaron, and we actually had 2 metrics. R squared is what people were ranked on, but we also had a secondary metric, RMSE, and this was what was used in the literature. So this is what we wanted to reproduce for the competition. Cool. I'm going to hand it off to Isha.
Great. Thank you, Christine. So the next competition we ran starting January 2023, and it was a competition to use remote sensing data to measure the biomass of a given region. And we worked closely with a partner at Peiyou Lewin University, who usually use remote sensing data to measure biomass and other sort of metrics related to the carbon stock or carbon flux of a forest. So pretty much how much change there is in the carbon capacity of a forest and the sort of static level of sort of carbon in a forest as well. So biomass is generally considered the sort of like total volume of biomaterials in a forest, if that makes sense. And one way that this was very, very traditionally measured is to go up to a tree, measure the sort of circumference of its trunk and the height of its trunk, and use that to estimate like sort of the volume of matter that the tree contained. And you would do this at sort of a representative sample across the forest, and that would give you an estimate of how much sort of biomass that particular patch of forest contained. So traditionally, this was a little bit of a destructive method. You would often have to cut down the tree to measure it. And then as sort of time went on, generally we shifted over to using LiDAR and other sort of like less destructive, but still sort of imperfect measures of biomass, including methods that were a little bit infrequent or low resolution. So at the time that we started this competition, it was the case that the sort of most high resolution, publicly accessible biomass map was something on the order of like 30-meter resolution. But we were looking to improve the resolution and the frequency with which we could estimate biomass. And the maps that were publicly accessible that were sort of the best before were, I think, also on a yearly level. So that was a competition we ran using Sentinel-1 and Sentinel-2 data. I worked with our partner to decide like sort of which regions of the world to focus on. We chose Finland because it had pretty good ground truth data, and it had ground truth data that was sort of like across a geographically wide enough expanse, was like high enough resolution. So we actually had labels that were 10 meter by 10 meter, which was going to be important to this challenge, seeing as it was to increase the resolution. And we had that on a yearly basis, and that was collected using LiDAR. And for the image data, for the features, we provided, again, Sentinel-1 and Sentinel-2 bands that we thought would be most relevant, along with a cloud mask cover as well. And the challenge for the participants was to take these about 13,000 individual patches of forest across Finland, for which we had ground truth data, and use the remote sensing data that we had to predict the 10 meter by 10 meter amount of yearly above ground biomass. So across an entire year, what is like the peak amount of biomass that 10 meter by 10 meter area has? And the metric for this one, I think might be on the next one. Yes, thank you, Christine, was average RMSE. And this was like also a little bit of a metric we constructed in consultation with the expert, which is that we measure the RMSE like on a pixel by a pixel basis for a given patch of land, which was, I think, 2,560 meters by 2,560 meters. And then because we wanted to treat each patch of land pretty equally, we just averaged across all the tiles. And our leaderboard is on the right-hand side. It's a little bit hard to like understand RMSE without comparing it to the benchmark. But the benchmark in this case, I think, had an RMSE of about 101. And so you can see on the leaderboard, we're getting an RMSE that's around like 27, 28. So quite an improvement over the benchmark. And as for the winners, they used an interesting sort of composite of features. So the way that the features were provided was on a monthly basis. So for the same patch of land, you had 12 different images taken for every month of that year. And the winners chose largely different ways to estimate biomass using those 12 images. The first and third place winners chose to just aggregate. So like no time series analysis, they're just distilling those 12 images down to, in the first place case, just one image for that one plot from 12. And the third place winner reduced it to 6. And there are different ways of sort of doing this aggregation, but both proved pretty effective. The second place winners did take a time series approach, where they sort of added time as like a third dimension and performed the time series analysis. And as is like pretty common with almost every computer vision competition we run, regardless of the sort of data, whether it's coming from like satellites or slides, for example, they were doing like flips, rotations, the normal pre-processing, and then or augmentation rather. And then as for the model architectures, all three of the winners used some variation of a UNet architecture. The first place winner used like a very standard UNet CNN, and then the third place winner used a UNet++ model. So same like very basic backbone, but quite different models at the end. And then the second place winner used a type of UNet model called a SWIN UNet R. So introduced some transformers into the architecture, and also derived that model from a sort of package of open source models that was originally intended for processing medical imagery. So quite like a different array of approaches. And I think to the question that was asked earlier about like the sort of size of models, the second place winners here definitely took a more resource intensive approach, right? They didn't do any aggregation. They used all 12. The model that they used was also pretty sizable. So we do see like different variations, but the first place winner used a model that was pretty standard, but ultimately had like a little bit more of like maybe a high impact or high efficiency pre-processing method that just collapsed 12 images into one without losing too much of the information. So this was about the outcomes we saw, and like all of our competitions, all of the solutions that won here were made open source and can still be found on our repo. Yes, Biplav?
Sorry, I'm asking a lot of questions here. These two competition, you organize this with, a larger organization, right? I'm wondering, like, what's the motive of these organizations? Pretty sure they have some existing workflow that they use. And then are they trying to survey different, machine learning, deep learning approaches that could solve the problem? Or what's the larger, the motive of doing this kind of competition for these organizations?
Yeah, that's a good question. And I can answer on the biomass front. We worked with a researcher at a university whose sort of area of specialization was exactly this. And he was finding it a bit frustrating that the highest quality and of maps that were biomass related and that were open were at like sort of a low resolution and quite hard to access otherwise. And he wanted to see if it was possible to use remote sensing data to achieve a higher frequency and higher resolution map. And so his goal was to sort of start with the sort of Finland data, which had very high ground truth data, but then eventually to expand this to sort of a global map. So it could be used, Finnish forests are very specific in their makeup, but perhaps it could be used for Brazilian forests or Chinese forests. So that was the overall sort of motivation, which was to create a resource that was an improved version of something that was already out there and that could be quite accessible to folks. And we actually partnered with someone who works on sort of Finnish forest management very specifically and creates an online product that enables forest managers to sort of go in and see the carbon stock and flux of their forests. So the ultimate, a sort of like side effect of this particular challenge's results was that this product maker was going to pick them up and integrate them in order to just provide not more information for researchers, but just folks who are actually making decisions about how to manage their forests. Yeah, Christine placed a map, the map that the results will hopefully be integrated in the chat.
I will add that this is a competition that was funded by MathWorks. And so occasionally we have groups that come to us that have an interesting data set, but they don't have the funds to provide a prize pool to run a challenge. And so MathWorks very graciously will fund some of these projects where they provide the prize pool and the money for us to produce the challenge, working with this data partner. So yeah, we're really fortunate that we've had a lot of competitions come through this funding route. The KELP competition is also funded through MathWorks. And I would say so this was like a pretty researchy competition just to see if this was possible, and also to produce a high quality data set using this existing LiDAR data plus the satellite data. I think the ultimate goal is to create a global data set. And all of this data is open, by the way, if you want to check it out and use it. It is the link to the open data page is on the competition website. And hopefully we can run another competition when we get more data for other regions.
Thank you. And I have following question on that, and I think you touched a little bit on that, Christine. I was wondering how one could get involved if they don't have funding, and if there's a mechanism like data driven themselves run this competition. the use case I currently have is the earthquake in Nepal. I'm currently helping a local organization there. It's, the earthquake happened in very remote area, so it's very difficult to get the data sets itself. B, it's also difficult for the first responders to go because there's these walking trails that haven't been mapped. It's very difficult to know where the breezes exist or the buildings. So I don't know if you have experiences running this competition for some disaster scenario or where there's no any funding available but is very interest to a larger community.
Yeah, I would say we've definitely funded that kind of competition before. And so what we will do if there's an existing funder, we'll go through with the partner and look for funding. And so that might mean applying to grants or finding just a third funder like MathWorks. That is something we'll often do. And so if you're interested in that, I would say that we should talk after. Great, I think we can do our last presentation.
Great. And Biplav, I just posted, we have a couple of competitions related to disasters. I just posted one in the chat if you're curious. So the last competition that we are going to talk about today is the Tick Tick Bloom Harmful Algal Bloom Detection Challenge. So the goal of this challenge was to use satellite imagery as well as some other publicly available climate and elevation data to detect harmful bacteria blooms in small inland water bodies. So the reason this is needed is that harmful algal blooms occur in water bodies all around the world. They occur out in the ocean as very large blooms, but they also occur as very small blooms in really important water resources inland, like lakes and lakes where people will swim for recreation and reservoirs for drinking water. So there are good satellite methods to detect blooms in the ocean, but inland, these blooms tend to be much smaller and a lot more dynamic. So there are not good methods to identify those blooms from satellite imagery. So the goal of this challenge was really to fill that gap for smaller blooms that occurred in really important water resources inland as an alternative to what is currently done, which is manual in situ sampling. So I think this is kind of a similar case to the Biomasters Challenge, where we're trying to help automate a very time-intensive process where in situ sampling is very time-intensive to perform. Public health managers can't test everywhere that they would like to test. So this is a way to give folks a more comprehensive view of potential threats to the water supply. We gave a little teaser of this earlier, but the labels for this competition were actually a really unique data set that we worked with NASA to collect. So we got in contact with over 30 public health organizations across the US who do manual sampling, and we aggregated all of their measurements that they provided to create one data set of in situ measurements across the United States. So these labels, each point is the cyanobacteria density, and cyanobacteria is just one specific type of harmful algal bloom. So each label is cyanobacteria at a specific point on a specific date. And again, the features for this challenge, we actually had participants access themselves using the date and location provided. And the main reason to do this is that, talking about motivation for partners, part of what they wanted out of this challenge was to get a sense of what data sets are most useful. So participants in this challenge helped with exploring a lot of different publicly available data sets, surfacing which features were the most correlated, which variables were the most useful. And so this is one of the modifications that we can do in our challenges that allows for help with exploring data sets that are out there. So in this case, the test label for people submitted was a severity level. again, this is a decision we made in challenge design because what folks on the ground use is not an actual density in detail in cells per milliliter. People tend just to need a severity bucket. We had 3 winners for this competition. We used region averaged root mean squared error. So similar to one of the earlier competitions, we had some areas of the US with much more data than others. So we had a lot of data from California, for example, but we wanted to incentivize models to perform well across the US and not just in areas with the most data, which is why we weighted by region when determining participant scores. And in this competition, actually, we saw that all of the winners used really simple tree-based models. So some folks in their write-ups talked about testing more complex convolutional neural network models and finding that the imagery resolution was just too low to support that, given how small some of these blooms are and some of the water bodies are and how quickly they move. And like many real-world data sets, there was some noise in the data that made it difficult to be precise enough to pick out really complicated features from something like a CNN. We also saw resolution of satellite imagery as a main driver of how people processed the imagery that they used. So even though folks couldn't get more complicated features from something like a CNN, they ended up finding ways to get useful predictive features from simpler statistics based on band color values. Another approach that the winning solutions used was to identify the actual water body in an image and then just use that part of the image to calculate these statistics. So a way to get kind of more sophisticated or more targeted features without using something like a CNN. So first place used the scene classification band from Sentinel-2, and second place used their own image segmentation code to determine what parts of a satellite image were actually the water body. And this competition, we actually were able to take forward through a phase 2 more direct consulting project. So not only are all of the winning models available in the winner repository, but we actually used those winning models, experimented with them and figured out what worked best, and created an open source Python package for finding cyanobacteria that is available for anyone to use. Any questions about this competition?
No questions, but thank you so much for covering a wide variety of applications here.
Yeah, absolutely.
I have a ton of questions, but I was politely waiting till the end. I just want to thank you all for the really fantastic presentation. I know this is just like a very a condensed version of 3 recent competitions. I was scouring your guys' website for the past year and a half, and I know there's plenty of great connection points on what the TensorFlow Working Group does and sort of other use cases that they may be interested in. I did have just a couple questions on scale. I know you highlighted leveraging data across the entire United States for these harmful algal blooms and sort of approaching it from that scale. I was kind of wondering, do you do competitions that are focused more for, say, a given country and only the folks from that country can participate? And just thinking about a really sort of nuanced question, and in particular, I'm thinking of small scale gold mining, which is sort of a contentious challenge. There's livelihoods associated with it, and there's a lot of nuance. And I was wondering, do you also sort of focus at, say, a country scale or a community scale and not just a totally public competition?
I can take that, and Christine, Isha, feel free to jump in. So we do competitions where the problem is at various different scales. So not all of them are global. Not all of them are the entire US. For example, the Biomass Challenge was focused on Finland forests. We have not done a challenge in the past where participation was restricted to folks just from a specific country. I think when we talk about the machine learning competitions versus our direct engagement, one of the things that is a major difference between those two tends to be making data public, where if you run a competition, generally the competition data has to be okay to make public, at least to the challenge participants. So that's one way we think about those different types of engagements. I did want to call out in terms of thinking about those more nuanced data problems. Another thing that we like to do is contribute to the practice of data science overall. And we actually have a package called Dion that is an ethics checklist for data scientists. So the focus of it is how to approach those more complicated questions, kind of in every data science project, the things to think about as you're going through it. And those kinds of more nuanced questions are some of the focus of the Pale Blue Dot Challenge and part of the spirit of open science.
That's wonderful. Yeah, that is a really, we'll definitely check out this link. I think that's something that this group in particular sort of is in that space. So thank you. I also wanted to mention, I think there's some good follow-ups that we should definitely discuss, especially around the biomass. There's a group here within the Science Coordination Office does a lot of work around biomass, and it would be, if you're thinking about other phases of this project and partners and things like that, I'll definitely connect you. And the last element I was going to mention, and we have like a minute left, but I'll eat up that time. Prizes and challenges. With NASA's prizes and challenges, I know that you highlighted at least two that were sort of funded in part through NASA and have this connection point to prizes and challenges. And Biplov sort of raised the question, like, how do we get involved, or so how do we channel projects? Because most of the folks who are coming to this group have some environmental challenge that they're working on that's necessitates some sort of machine learning or deep learning, and we're thinking about maybe some candidate projects or collaboration points. So do you imagine tapping into prizes and challenges a great first step, or do we just find all these offline?
Sorry, what do you mean by tapping into prizes and challenges?
Yeah, so we've had some participation in some projects with prizes and challenges here at the Science Coordination Office in the past that are been sort of generated from our office, but they're all they're not broad competitions in the sense that we're like trying to crowdsource a solution. So we have some interaction. Obviously, we're within the same sort of portfolio, but we're not taking advantage of the crowdsourcing approach.
Gotcha. Go ahead, Katie.
I was going to say, I think through NASA, we tend to coordinate with COSI, so Center for Excellence for Collaborative Innovation. So I think in all of our projects with them, they've been involved helping to coordinate it. They might know the process internally at NASA for working on getting funding. Another option is always, we're happy to just talk through. We're always looking for new and exciting projects to do. We're always happy to talk through problems and think about, machine learning competition versus direct engagement, or what a possible project could look like.
Yeah. And I think the person to talk to is Greg, whom you've talked to before. So let's definitely continue this conversation offline. I think there are lots of really interesting ways that we could collaborate. So yeah, let's do that. I did want to add a caveat to what Katie was saying before about competitions that are limited to certain countries. I think Katie's answer was great. I do want to caveat that we have had some competitions that are where the winners are limited to US residents. And so to win money, you have to be, if you're on a team, the team lead has to be a US citizen or resident. And we've also had competitions that were limited to just university students. So you have to have a .edu email address to participate. And beyond that, we have used our platform to run competitions for just internal groups. And so like for student projects at universities or something like that, only the students in that class are able to access this portion of the website. So we have done limited things like that, but the US is still fairly big, and so nothing super limited.
Wonderful. Yeah, thank you so much. Any other questions on the line? I know we're already over, but just wanted to, I know I used the last 10 minutes to ask all my questions. So any other questions on the line?
Yes, I would like to ask something first. Thank you for the lecture. It was really interesting. Unfortunately, I don't live in US, and I am not from US. I'm living in Europe. And one question, because I'm doing my PhD, I want to know, I don't know if you mentioned, is it connected, all the results, also with publication in scientific journals, or just in it sharing, it's something that you share publicly in the GitHub? I couldn't get, I don't know, I'm so sorry if you mentioned and I couldn't get it. And yeah, that's all. And thank you for the second one. I'm working in the agroecological field, and the biomass is something that we talk almost every day, and the information will be really good for us. Thank you.
Yeah, I will say several of our partners have gone on to publish academic papers with the winners of the challenges. And so for the Biomasters Challenge, they recently published the data set in the NeurIPS conference in the benchmarks and data sets section. So that is a recent example. We had a previous competition called Magnet, which was predicting magnetic interference as with the Space Weather team at NOAA, and they published the results along with the winners. And so, yeah, we have many examples where the winners have gone on to co-publish papers with our partners who provided the data. So definitely that's something to look into.
Wonderful. Well, again, I just want to thank the entire DrivenData team. It was a very fantastic presentation, and hopefully we'll find more inroads to collaborate. And you guys are always welcome to join the TensorFlow Working Group. This is an open call, so feel free to join for any future calls as well. So thank you, and we'll be sure to get the recording out soon. Thanks, everyone.
Thank you so
very
much.
much.
Thank you.
Thanks all.
Thank you.
Bye-bye.
Thank you.